Hey everyone, it's Mrs. Hageman again. This is the second video for Chapter 8 Similarity Notes, and this is going to cover the second objective that we can use the angle-angle similarity theorem to show that triangles are similar. So slide 8 is a reference slide about the theorem. Angle-angle similarity theorem says that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar, okay? So in this case, angle A and angle D have one loop, so they are congruent. Angle B and angle E have two loops, so those are congruent. And that is enough to say that triangle ABC is similar to triangle DEF. Remember our squiggle, our one, that's a symbol similar to a tilde in Spanish class. So that one squiggle means is similar to. Now, this is the same as saying that we have three angles congruent, angle, angle, angle. Because if we have two, then we know the third would match because all triangles add up to 180. So we have an example here. We want to determine whether these triangles are similar. Okay, you want to try to find all the angle measures because just by looking at this, it looks like we only have one angle in common. We have our 21s. So we have angle X is 21 degrees and angle R is 21 degrees. That is only one angle for the angle-angle theorem. So we need another angle that is congruent in order to select yes. So we have 98 for angle Z. We have 61 for angle T. So what you want to do is you want to try to find these unknown angles like angle Y and angle S. And if you get one of those to match one of the other angles in the other triangle, then we'll be able to say, yes, these are similar. Remember, the angles in a triangle add up to 180. So the triangle on the left, if we're trying to find angle Y, we might do 21 plus 98, which equals 119. And then we can subtract 119 from 180 to figure out what's left over. And that gives us 61. And what you want to notice is we do, in fact, have a 61 in the other triangle, which is angle T. So angle T and angle Y are both congruent. And so that is enough to say yes because of the angle-angle theorem. Two angles are congruent in each triangle. If you were to do the triangle on the right or to continue your calculations, you would find that 21 and 61 gives you 82. And if you subtract 82 from 180, you get 98 degrees, which does in fact match to angle Z. So these are congruent angles as well. All right. So if they are similar, which they are, we're going to finish the similarity statement. So triangle XYZ is congruent to triangle RTS. T matched with Y and S matched with Z. Slide 10. Again, we need two angles that are congruent in order to say that these triangles are similar. So determine whether triangle AEB is similar to triangle ADC. So we do have one pair of angles congruent. We have angle B and angle C. And then I'm going to redraw the top triangle so I can show you guys that we have another angle congruent by something called the reflexive property. So angle A is in both of our triangles. Okay, it's in the larger triangle, ADC, and it's in this smaller triangle that I'm redrawing for you. So we have angle B, okay, and I'm actually going to put that 52 in this one as well, so you guys can see that. And so I've just pulled this top triangle off of there. Okay, so we have angle B is congruent to angle C. Okay, and so this top triangle now has been taken off and put there. And so we have this larger triangle, triangle ADC. And I'll highlight that So let's focus on this larger one, comparing it to the smaller one. So we know we have 52 for those. And then I want to point out that angle A is also going to be the same because it corresponds to itself in the statement. Angle A and angle A are both the first letter of the triangle statements. So we know that angle A is going to be congruent to angle A, whatever it might be, by the reflexive property. And there's another way to look at these triangles based on the angles down at the bottom. Um, we don't have equal angles, so E and D are both not 52, but they do equal one another, okay? If you remember from chapter 3, anytime two angles equal each other and they are shared with two lines, these lines are going to be parallel. Okay, we know those lines are parallel because we have corresponding angles. And those make parallel lines. And this is something we talked about in chapter 3. So there's a theorem that says anytime corresponding angles are congruent, and that goes along with alternate interior as well. When we studied corresponding, we studied those as well. So anytime we have corresponding angles congruent, those are going to make our parallel lines there. So if the lines are parallel, then we know we have another set of congruent angles, whatever those might be. Okay, so because the lines are parallel, not only are the angles going to equal each other on the right, but the ones are on the left, angle E and angle D, are going to be the same size as well. And I should have made angle A 2 loops here, because that was the second angle we did. So most of you should be able to see reflexive property, an angle equals itself. But we also have this idea of corresponding angles being congruent, which would be B and C and E and D. So your corresponding angles being congruent would make those lines parallel. So this is going to be a yes. And we're just going to retype everything we had in that box there. And we'll put it in our explain your thinking. And don't forget, we did say in the beginning that angle B and angle C are both 52. So we did have two angles congruent with angle A and angle A. And then you can go further and say angle E is congruent to angle D. Right, so we could prove these parallel by the angle-angle similarity theorem. I'm sorry, we could prove these triangles similar by the angle-angle similarity theorem. Slide 11, determine whether triangle CDF is similar to triangle DEF. And so we're going to want to add in any of our information in terms of the angles. We have one right angle, so that means we have another right angle. So far we have one angle that matches. And then we want to treat this just like the first one we did where we found angle measures. So if you calculate the sum of the triangle being 180 of this larger triangle to the left, okay, angle CDF at the top, we don't want to just say angle D because there's two possibilities there. So CDF, which is the angle in the triangle on the right, is going to be 58 by doing 180 minus 32 minus 90. That's how we get 58 there. And then once we have that, we are done because we have two angles. We have two of our 90s. And we have angle CDF and angle ER 58 degrees. Again, you could go further and find the other angle at the top on the other side for that smaller triangle, and that in fact would be 32 degrees by doing 180 minus 90 minus 58. So we do have our third angle there, which we could find. We don't need it. Remember, angle is the same as saying angle, 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 okay, and finding 3, but minimum we need 2. So angle C and angle FDE are 32 degrees, if you found that one. Okay, so these are similar. And I know we've had all yeses here, but just watch out when you do your practice later this week for any time you do not get any angles matching up together, and then it would be a no. So anytime you do not get 58 and 58 or 32 and 32, then we would select no. But we do have all of our angles congruent here. And our last one is a proof. Proofs always start with given. We know it's given because they told us. We have these arrows here that tell us parallel. RS is parallel to TU. And then we have 2 angles, angle RSV, which is just like saying angle S, angle TUV, like angle U. Anytime you have 2 parallel lines cut by a transversal, that forms alternate interior angles. Alternate interior angles are congruent. And again, those are the 2 angles that are meeting where the transversal, the diagonal SU, is intersecting the parallel. So angle S and angle U. They have it named with 3 letters here. RSV, S is in the middle, and angle TUV. U is your middle letter. So those are alternate interior angles. We're not going to use midpoint. We're not going to use angle bisector. We're not going to use reflexive property here. And then we have step 3. Angle SVR is congruent to angle UVT. You want to notice the middle letter is V. So the 2 angles that are in the intersection of where V is, again, not midpoint. That's talking about a point or a segment. Angle bisector is typically 2 angles next to each other, not across from. Okay, so step 3, your reason is vertical angles are congruent. Remember, vertical angles form an X or 2 V's. And now we have 2 pairs of angles in each triangle. So we have angle S is congruent to angle U, and then our 2 vertical angles. So that is enough to say that triangle SVR is similar to triangle UVT by the angle similarity theorem. And check and make sure it's in your word bank, which it is. And so that finishes part 2 of these slides on Learning Target 8.2.